are back and we are continuing with our computer science. And we have seen that we have 10 topics to cover, right? And we have gone through the 6 for the computer systems, which we said is the theory. Now, what we want to do is we want to talk about algorithms, programming, and logic, which is the second paper. That is what we have agreed on. And we are starting with chapter 10 because it's the easiest one. Get it out of the way. We go to the next one and to the next. And the 10th chapter, we only have 4 to do in this paper too. We only have 4 topics. And we are doing this, which is as the first one. And that is Boolean logic. It's by far the easiest one. Okay, so let's go through it. Let's go through Boolean logic, and we're going to be talking about it right now. What is it that we're going to look at first? We're going to look at logic gates. This is the very first thing we're going to be looking at and talking about. And now you have to know all the logic gates, and you have to know their truth tables, and we're going to build up from there. So the first thing is for you to know what we call logic gates. And then I'm going to be building you up and telling you the next thing and the next thing and the next thing until you're good at this whole thing. So if you know logic gates, then you have done a big part of this topic. Now you say, what are logic gates? Logic is what? Thinking. So this is how a computer is making decisions. It uses these things. And let's see how it gets to its decision. First, we start with the first gate, which is going to be called the AND gate. Now, the AND gate, I want you to know that when we meet the word AND in computer science, it means multiply. So AND is to multiply. So what does the AND gate do? It multiplies the two inputs. So almost all the gates you're going to do, except for one, which is the NOT gate. But all other gates get 2 inputs, then they combine those 2 inputs to give you one output. And you must know how each gate combines the 2 inputs. Now, the AND gate multiplies. When you meet the word AND in computer science, and when you meet the word AND in maths and probability, you should know that the word AND is just saying to you, please multiply the things you have. So for computer science, you'll be multiplying the 2 inputs, and our inputs are going to be A and B. So let's draw what the gate looks like, and then we are going to put the truth table which multiplies them. So we have one input code A, the other input code B. And these 2 inputs are coming into the AND gate. When you draw the AND gate, make sure that the back of it is flat like this. Okay, and make sure the 2 inputs are going right into contact with it. Then you draw a belly like that. You put a belly, and then you put a straight line to your output X. This is the AND gate. Now, what you know is, remember, in brackets, you don't have to put it anywhere, that X is just A times B. This dot means times, okay? It's A times B. So now let's put it. Let's put our truth table. We like that, don't we? Let's go for it. So what is our truth table? Truth table is just something which then tells you what this gate does. So here is our truth table. What are we going to say? We are going to say, okay, every time you do a truth table, remember to put 4 inputs, okay? 4 different input combinations, unless it is the NOT gate. The NOT gate will only have 2. So here is, we write to say, here is our truth table. Here is our truth table, right? What is it going to have? What is our truth table going to have? It is going to have input X, input A, input B, and then the output X. That is the truth table. So it is going to have input A, input B, and output X. So here it is. What are we going to now do? Now, what are the different combinations? You can have 0, 0. You can have 0, 1. You can have 1, 0. And you can have 1, 1. These are the 4 different input combinations. 0, 0, 0, 1, 1, 0, 1, 1. Okay? You must remember. Now, what does it do? It's easy. What you're doing is easy. Remember, what must it do? Multiply the inputs. So what is 0 times 0? a 0. Now you must know that, remember, in computer science we said we do binary, and remember, binary, it is when you have only two types of digits, a 0 and a 1, which we can say a low and a high. Okay, a 0 and a 1. The highest you can ever have is a 1. You can never go beyond that. Okay, so either you're going to have a 0 or a 1. Now let's do it. What is 0 times 0? Of course that is 0. What is 0 times 1? Whenever you multiply a number by 0, it's 0. So what is 0 times 1? It's 0. The answer is 0 because you're multiplying by a 0, right? What is 1 times 0? It's 0 again because you're multiplying by 0. What is 1 times 1? It is 1. So this is going to be the truth table. You need to know the inputs and then you need to know the outputs. Now, what is the other gate? The other gate is the OR gate, okay? The OR gate. Let's go for it. 2, I'm going to put the gate, which is going to be the OR gate. The next gate to know is going to be the OR gate. Now, what happens with the OR gate? The OR gate is add, probability, and computer science. Remember, and you multiply, or you add. When you see the word or, you are going to add. So here we have the OR gate. What should we do? We should add the two inputs. So now you should say, okay, I now know what we're going to do to the OR gate, OR gate in the truth table. I'm just going to add the two inputs. Please show me the shape. Show me the shape of this gate, because remember, I'm going to have a logic circuit, which is I may be asked to draw eventually, or I may be asked to make up the solution, to make a logic circuit, to fill it up, a truth table, a very big one. So how do I draw this gate? Okay, we're going to get to that stage where we are going to be doing those nice big questions. But here are the inputs: input A, input B. Now, how does the OR gate differ from the AND gate? The AND gate is straight at the back. The OR gate is going to be curved at the back. That is the only difference, okay? But then afterwards, put the belly, please. Put the belly. And then put the output X. There we go. The output X. Okay? Just make sure your OR gate is curved at the back. If it is not, you are wrong. So there we go. Now, what is the truth table like? Well, let's put it. We should now be fast. We are going to say truth table. Then we are going to have input A, input B, output X. There we go. So we're going to show this and put our table. How easy is this? This is very easy, isn't it? Very, very easy. So now let's put the truth table. Let's fill it up. Let's fill it up. What did we say our truth table has? How many things? How many combinations? 4 combinations. What are the combinations? 0, 0, 0, 1, 1, 0, 1, 1. Okay? 0, 0, 0, 1, 1, 0, 1, 1. You can't forget this. Now what do? You add the inputs. But remember, the highest value you can ever get is a 1. Computers think in zeros and ones. You can't go to a 2 because that number does not exist in binary. It doesn't. So what is 0 plus 0? It is a 0. What is 0 plus 1? It is a 1. What is a 1 plus 0? It is a 1. So remember, for an OR gate, that your X, which is your output, is equal to A plus B. Remember that. You add, right? Okay. So what is now 1 plus 0? It's a 1. What is 1 plus 1? 1 again. You can't go to a 2. Okay. 1 plus 1, you will stay at a 1. You understand? That is what you do. Now let's do the third gate, which is a walk in the park. Third gate. This gate, we do not even fear it. We do not even respect it. This is a walk in the park because it only has one input. We said it. It is the only gate that has one input. You say, what? So how is it going to combine? Let's go and see. The NOT gate, you need to be good at this one because it is going to then tell us how we are going to do the next 2 gates as well. So the NOT gate is just a gate that inverts the input. It flips the input, or it inverts the input. Okay, that is what it does. That is all it does. And if you see it as a sign, they say that when you want to get X, it is just going to be A complement. It means the opposite of A. Okay, you invert A. That is what we mean by A complement. So it means not A. Okay, which means you invert A. Whatever the input is coming, flip it to the other one. That is simply what the NOT gate does. So it has only one input. You show it like this. You put a nice triangle. And there is something you should never forget about this gate, is that it has a small circle in front. And this is going to help us recognize anything that has to do with the NOT gate. It will have this small circle in front and then your output. What is our input? A. What is our output? X. Okay? We don't have a B this time. We don't have two inputs. Then we are going to put our truth table. Let's put. So we are going to come here and say truth table. Okay, we're going to come here and we're going to say truth table. But what a simple truth table we have this time. We only have one input, A, and then we have our output X, right? And how many combinations are we going to have for a NOT gate? 2. You don't have 4 like the other ones because you only have one input. So you are only going to have 2 types of things in the truth table. So let's put it. We can have a 1 or we can have a 0. These are the only 2 types of inputs. So now, when it comes in as a 1, it flips. It becomes 0. When it comes in as a 0, it's flipped. It becomes 1. And this is going to be the truth table of the NOT gate, or the truth table for the NOT gate. Here we have the first 3 gates, and we can go on and on and on. Now I'm seeing that my time is at 10:48, so I'm going to put the next gates in the next video. Goodbye for now. We'll meet in the next one.